Construction work is screened from view and limited access is maintained by a 10-foot-high fence around the project staging area. Access to the project is created by the excavation of a 30-foot-wide road along the south side of the building. Ramps at each end will channel trucks, material, and equipment to and from the site. The first step in construction will be the excavation below the building. It will progress in slots between the rows of existing footings using 2 simultaneous crews. Using a combination of as-built information and new survey data, existing utilities such as sewer lines will be located before underground excavation begins. Then, relocated into adjacent bays to ensure uninterrupted utility service. The initial excavation will be 4 feet 6 inches below the existing footings with shoring put in place to hold up the first floor slab. The use of specialized excavation equipment will reduce noise and vibration to minimize impact on the occupied facility. To protect the building from excessive vibration, a vibration monitoring system, or VMS, will be installed before any construction activity begins. The VMS will consist of vibration sensors placed underneath the second-floor photolithography areas and at the photomask area on the first floor. These sensors will be tied to on-site computers which will sample the data to ensure that vibrations are within acceptable tolerance levels for production. In the event that construction vibration approaches unacceptable levels, the VMS will send a stop signal to the work area until the cause of the vibration can be found and eliminated. Upon completion of the first pass of excavation, drilled piers will be installed at the corners of each existing footing. This work will progress down each of the excavated slots close behind the initial excavation. First, specialized equipment will drill a 2 feet by 18 feet deep caisson. Then, a rebar cage is installed, and the caisson is filled with concrete. This creates a platform for the installation of the steel underpinning beams. The underpinning beams, jacks, and spacers are installed beneath the existing footing. The load of the building is then transferred from the soil beneath the footings to the piers. First, the existing columns are core drilled and steel reinforcing is installed and epoxied in place. Then, the steel beams are installed and a rebar cage is fabricated on top of the existing footing. A rebar mat is extended along the beams. Pressurized concrete is pumped into the area above the footing, encasing the steel beams and rebar reinforcement. Finally, shotcrete is spray applied to the mat above the beams, creating a new 5-inch slab that provides additional lateral support. Completion of the new slab and beam foundation allows the temporary shoring to be removed and the second phase of excavation to proceed. The remaining earth between and below the existing footings is removed to the final depth of 13½ feet, utilizing both hand and machine excavation. New steel reinforced concrete footings are poured at the final depth, which will be used to support the base isolator assembly. The bottom of the existing footing is core drilled and the upper bearing plate is bolted in place. The isolator pedestal is steel reinforced, the lower isolator bearing plate installed, and then poured with concrete. The isolation assembly is now ready for the isolator installation.